Good evening, everyone. Today we'll discuss about the transition curves. So last time we discussed about the circular curves. The basic difference between a circular curve and a transition curve is that in case of circular curves, we have a constant radius. But in case of transition curve, the radius is not constant. It is continuously changing. So this is the basic difference between a circular curve and a transition curve. So let us discuss the definition of transition curve first. It is a curve which is also known as easement curve. It is a varying radius curve. Now, in case of circular curve, the radius is constant, but in case of transition curve, the radius is varying, and it is introduced between a straight and a circular curve. In case of circular curve, the curve is started just adjacent to the straight road. Okay, but in case of transition curve, it is provided between a straight and a circular curve, or between reverse curve. Okay, so a transition curve is nothing but a varying radius curve. The radius is not constant, and it is introduced between a straight and a circular curve or reverse curve. Now, what are the functions of transition curve? Basically, this transition curve is provided on important highways and railways. On every expressways, we have the transition curve, not the simple curves. Okay, so what are the functions of this transition curve? The first function is, if transition curve is not provided, then what will happen? There will be an abrupt change in the alignment. That is, the alignment is suddenly changes from a straight to a circular curve. Okay, so which not only provide discomfort to the drivers, but also become a major reason of accident, because the curvature suddenly changes from a straight to a circular curve. Okay, so that gives discomfort to the driver as well as to the passengers, and it becomes a major reason for the accidents on the highways if transition curve is not provided. And second function is, in straight portion, you know that the central portion of the road is slightly higher as compared to the side of the roads. Okay, on a straight road, that raising of the central portion is called camber. So in straight portion, camber is provided in the middle part of the road, but at the curve or at the turning, super elevation is provided in outer part of the road. So on the curve, we have outer end of the road is raised with respect to the inner one. That is called your super elevation. Now, to change the slope smoothly from camber to super elevation, that is, we have to change the slope. Initially, when the road is straight, we have provided camber, and at the curve, we have provided super elevation. So there is a continuously change of slope from a straight road to a curve. Okay, so to provide this change smoothly from camber to super elevation, and then again super elevation to the camber, a transition curve is provided. So we require a certain medium for the provision of this camber to super elevation, and again from super elevation to camber, you need a certain medium. That medium is called your transition curve. So these are the two functions of the transition curves. Now, what are the conditions to be fulfilled by transition curve? You will first I will show you the picture here. This is my straight road. Okay, this is my straight road. This is my deflection angle. Now, from here to here, C to C dash, this is my circular curve. Okay, if I extend this curve here, this is my extended portion here, and this is my extended portion here. But what I will do in case of highways and railways, important highways and railways, we have provided a curve of varying radius from here to here. That is, from the point T1 to the circular curve. This region is your varying radius curve here. So this varying radius curve is nothing but your transition curve. Similarly, this is the end point of the circular curve. After this end point and again this point T2, I have to introduce a varying radius curve again here in this region. That is called again your transition. So in the central part, on the important highways and railways, we have to provide a circular curve in the middle here, and on the two ends we have to provide the transition curve. So one curve is here and one transition curve is here. Okay, So what are the conditions to be fulfilled? Number one, it should be tangential to the state. Now here, at this point, this is my transition curve, this is state, it should be tangential here. Okay, this is the first condition. It should meet the circular curve tangentially. Now this transition curve should meet the circular curve here, it is tangential here. Tangential here, tangential here. Then its curvature should be 0 at the starting point on the state. The curvature of the transition curve at this starting point on the state road is 0, or you can say that infinite. Okay. Its curvature at the junction with the circular curve, here the curvature should be same as that of this circular curve, that is radius r here. The rate of increase of curvature. Now from here to here, okay, the curvature is increasing. The rate of increase of curvature along the transition should be same as that of superelevation. Now we know that whenever there is a curve, the outer end of the road is raised with respect to the inner one, that is called your superelevation. So the rate of increase of curvature from this point, that is the curvature is 0, and at this point this is your r. So rate of increase of curvature should be same as that of the superelevation. Okay. The other name of superelevation is cant. Now its length should be such that full cant or superelevation is attained at the junction with the circular curve. The length of the transition curve should be such that full superelevation or cant is achieved at this point, that is at the junction of the transition curve with the circular curve. So these are the some of the conditions that should be fulfilled by transition curve. Now what is the meaning of superelevation or cant? Okay. Now look here. In this diagram, this is my road here. Okay. This is about the straight, and then we have a curve here. So we'll notice that this is my center line of the road, this one, CL, center line. Now, on the center line, we have the road is raised higher at the center with respect to the two edges. So this elevated portion, that is called your camber. Okay. Now, when the curve starts, so this is my curve. So what will happen? Slowly, what will happen? Now here, this camber, half portion we have a camber here. Then in the remaining half portion, it is straight, because I have to introduce the super elevation gradually. So here the raising of outer end is 0 here. Okay, but we have raised certain portion of the road here, outer end only. Okay, so some amount of super elevation is added in this length. Then again at this curve, what will happen? Again the super elevation is increased. Now this end, which is exactly horizontal here, that is raised slightly, slowly, and it becomes here. This is slope here. So we have a slope here and we have a slope here. And finally at the curve, what will happen? The outer end of the road is raised completely. That is, we have full super elevation is attained here. Okay, and we have this straight portion, inclined portion here. Okay, so this is called my super elevation. That is full super elevated section here. This is partially super elevated section. This is again partially super elevated section. There is no super elevation here. Only the camber is here at the center line. Then after the curve ends, what will happen? Again, I have to reduce the super elevation. Okay, so at this position, this is your straight line here. Okay, then at the end, what will happen? Again, the super elevation here is 0. Here it is 0, and in the center we have a highest portion, that is nothing but your camber, as it is here. Okay, so in this way we have to provide the super elevation from on the curves. Okay, now what is this? It is the distance by which outer end of the road or rail is raised above the inner one. Now look here in this diagram, this is my curve. Okay, the outer end of the road is raised by a height h. Okay, the width of the road is your b. So how much height h is here? That is called your super elevation or cant. So it depends upon the radius of the curve and the speed of the vehicle. This how much it is raised, that is depend upon two factors. One is what is the radius of this curve here. Okay, how much is the radius of this curve, and second, what will be the design speed of the vehicle on the curve. So let us discuss what are the various forces acting on a moving vehicle. This vehicle is moving on the curve. So number one is the weight of the vehicle. that is this W here. Okay, and second is your centrifugal force. So whenever a vehicle is moving in a circular path, we have a centrifugal force which is acting in the outside direction. That is your P. So this is my centrifugal force. So let W is the weight of the vehicle, P is the centrifugal force, V is the speed of the vehicle, design speed, G is the acceleration due to gravity, B is the width of the road from here to here. Okay, and capital G is nothing but the distance between rails. That is called your gauge. Now, in case of railways, we have provided two rails on which the wagon is moving. Okay, so the distance between the two rails at the top is called your gauge. Okay, and R is the radius of the curve. Theta is an inclination of the road or the rail surface. This is the inclination theta here. Okay, now uh, I have to calculate the expression for this super elevation. What is the amount of H here? Okay, so we'll see here. This is your car. It is moving on the road. So this super elevation is dependent upon two factors, as I told you. That one is your centrifugal force, which is acting on the outer side of the curve, this force, and second is the speed of this moving vehicle. So this is the super elevation, that how much amount of this outer end of the road is raised with respect to this inner value, that is called your super elevation. That is given here, it is your H. Okay. So here, you know this relation, you have studied this relation in your 11th class physics. P is equal to centrifugal force is equal to mv square over r. Okay. So m is nothing but your mass of the particle, v is the speed with which the mass is moving, and r is the radius of the circular path. So we can convert it in terms of w here. So m is, you can convert it, m is equal to w over g here, v square over r. So P by W, W is taken on this side. So this is P by W is equal to V square over GR. This is equation number 1. Now what is this P by W here? If you see this diagram here, okay, this is my P here. This is perpendicular. And this is my W, that is your base. Okay, so this is nothing but tan theta, perpendicular upon base. So P by W is nothing but your tan theta. So this is equal to V square over GR. So this is my equation number 2. Now, if H is the super elevation, we have, now this tan theta is nothing but your H in this diagram. So this is your H. So H is equal to, this is my B times of tan of theta. So B times tan of theta. So here, in place of tan theta, I write V square over GR. So this is equal to B, V square over GR. So this is the expression for calculation of super elevation on the roads. You have to put the design speed here, you have to put the value of R, you have to put the width of the road. You will get the amount of super elevation. Generally on the curves or on the highways, the design speed, maximum speed of the vehicle is restricted. Suppose that we have 100 kilometers per hour. So just put 100 here. Okay, we know the width of the road, we know the radius of the road. So we have to find out what is the value of H. Similarly, H is equal to, for rails, okay, for rails in place of B, width of the road, we have to put gauge, that is the distance between the rails. So G times tan theta. So here in place of B, only the difference is here it is G. So this expression is valid for railways. Other terms remain the same. Now, what are the types of cant or super elevation? So basically there are two types. One is called equilibrium cant and second one is called deficient cant. Now what is the meaning of equilibrium? Now look here, this is my vehicle is moving on the curve. We have, this is the amount of super elevation. So depending upon the speed of the vehicle and the width of the road, I put B here and B here. We know the radius R, so we have calculated this H value here. So this is the amount of super elevation which is required for the vehicle to pass safely on the curve with a certain design speed V. Okay. So if cant is provided by this relation or by this relation, then what will happen? The load carried by both the wheels will be same. We have the springs here on the just above the these wheels. Okay. So load carried by both the wheels will be same, the springs will be equally compressed and the passenger will not tend to lean in that either direction. Generally, you will notice then when you are moving in a vehicle, okay, in a bus, okay, uh, and you are on the curve, you will lean to one side of the bus. Why? Because of this difference. That is, in that case, super elevation is not provided as per the requirement. Okay, if it is not provided as per the requirement, then the passenger will tend either to the left or to the right while moving on a curve. Okay, so that is called your deficient cant. If h is less than the desired value, then it is called deficient cant. If h is provided exactly by this relation or by this relation, then in that case the passenger will not tend to leave in either direction. They are moving, they are sitting as a straight position. Okay, they are not leaning in either direction. Then it is called your equilibrium cant. This cant is known as equilibrium. Now, what is deficient? If h provided here is less than this value or this value, then what will happen? The passenger will either move to the left side or to the right side. They are leaning. Okay, so this cant is called your deficient cant. So the track under these conditions have a cant deficiency. Clear? Now, what is centrifugal ratio and what is the use of this centrifugal ratio? It is the ratio of centrifugal force which is acting on the outside to the weight of the vehicle. Now CR, centrifugal ratio, this is my centrifugal force, this is my weight of the vehicle. Now centrifugal force, I already drive this relation, WV square over GR, this is my P here, and W here, 1 by W here. So W cancels out, we have V square over GR. So what is the maximum value of CR and why it is used here? The maximum value as per IS code is 1 by 4 on roads and 1 by 8 on railways. Okay, we have two values here for roads as well as for railways. Now what will happen? P by W is nothing but your centrifugal ratio, and it is 1 by 4 equal to 1 by 4 on roads is equal to V square over GR. Okay, so using this relation, I can find out what is the V. So V is equal to under root of GR by 4. Okay, for railways, P by W is equal to how much? 1 by 8 is equal to V square over GR. So V is nothing but GR over 8. Now using these two equations, 5 and 6, these equations decide the minimum radius of the curve for the vehicle to pass safely with the given speed. Now we know that the design speed on the highways is, we have a specified design speed. Suppose that the highways and expressways are designed for 100 kilometers per hour. So we know this V value here. Okay, we know G value. So using this relation, I can calculate what is the minimum radius of the curve which is required on the expressway to pass safely with the given design speed. So this expression is used to find out the minimum radius of the curve on the roads or on the highways, and this expression is used to find the minimum radius of the curve on the railways. So these are the application of centrifugal ratio on highways and railways. Okay, just to find out what will be the minimum radius of the curves. Now next is your, what is the length of transition curve? How it is decided? How much length is this required? So there are three methods of finding the length of transition curve. The first method is by an arbitrary gradient. Okay. Now what is this? In this method, the super elevation, that is h, is provided at an arbitrary rate, say 1 in n. As I told you in the class that in civil engineering we have to designate the slope as 1 in n. Means when you are moving n meters horizontally, your elevation changes by 1 meter vertically. Okay, so this is the meaning of 1 in n. Then length of transition curve is given by L is equal to n into h. Okay. Now what is what is L here? L is in meter, that is the length of transition curves. Now n is an empirical number which is varying from 300 to 1200. So you just put the values here. Generally we have to put the highest value here. Okay, so that the length of the curve will be higher on the safer side. So the second method is by time rate. Now what is this? L is nothing but again the length of transition curve which is in meter. H is the amount of super elevation in centimeter. Okay. Application of super elevation is, what is the meaning of time rate here? Time rate means application of super elevation is x centimeter in 1 second. That is time rate. So super elevation is provided in as x centimeter in 1 second. V is the speed of the vehicle in meter per second. R is time rate. The unit is centimeters per second here. That how much super elevation is attained in centimeters in 1 second. Time taken by the vehicle to pass the transition curve is how much? You know that this very simple relation, time is equal to distance upon velocity. Okay, so L upon V in seconds. Super elevation attained in this time t will be how much? So just multiply by time rate, which is nothing but your R here. So T into R. So T is L by V into R in centimeter. Okay, so this is equal to L upon V into R. So at the full super elevation, this is equal to H. That is at the junction of transition curve with the circular curve. So this is my second expression for the length of transition curve. So L is equal to how much is it? H into V divided by R in meter. So this is the first method for calculating the length of transition curve. This is the second method of calculating the length of transition curve. We have one more method, that is method T, by rate of change of radial acceleration. Again, L is the length of transition curve in meter. Alpha is nothing but rate of change of radial acceleration, which is used in this method. Unit is meter per second square per second. V is the speed in meter per second. Now time taken by the vehicle, again same relation, T is equal to L upon V in second. Now in this time, how much radial acceleration attained? Just multiply this time by alpha here. Okay, so alpha into, in place of T, it is L by V, meter per second square. Now you know that you have already studied in physics, radial acceleration on circular curves is given by V square over R. Okay, so just equate the two radial accelerations here. So alpha times L upon V is equal to V square over R. This is equal to this. Okay, so from that L is equal to length of transition curve is VQ over alpha R. So what is a value of alpha? We are generally taking alpha is equal to 0.3 meter per second square per second. It is standard here. It will pass unnoticed to the passengers. Okay, so basically these are the three methods of calculating the length of transition curve. Okay, this is the third method. So you got three values of transition curve. The maximum value you have to adopt on the safer side for the length of transition curve. Thank you so much.